Okay, this is the P4 paper from January 2023. It's question number 8. If I make it a little bit smaller so you can see all of it. This is a parametric equation question, but it's one where we're going to be trying to find the equation of the normal. That's going to be differentiating, and then we're going to try and find the area under the curve. That's going to be integrating. So let's make a start. It's 11 marks, 5 marks for the first part, 6 marks for the second. So for the first part, what have we got to do? It says, can we see if we can work out the equation of the normal, the equation of this straight line here? Well, if I'm ever trying to work out the equation of a straight line, I'm going to be using y minus y1 equals mx minus x1. x1 and y1 will be a coordinate, in this case p, and m is going to be the gradient. So the gradient of this normal here, what I'll have to do is work out the gradient of the tangent, which will be finding dy by dx, and then the gradient of the normal is going to be minus 1 over that. Well, I've got to go and say all that to the examiner, so I may as well get started here. So part A, I want to work out m first. I want to work out the gradient, so I've got that x equals sine squared t. Now, I sometimes say, you don't have to, but I sometimes say to my students, if you write this as sine t squared, that might make it easier when you're differentiating. If you don't need to, then don't do it. But differentiating this, it's something squared. So something squared is 2, the something, 2x, but then multiplied by the differential of what's in here, and the differential of what's in there is cos. So we get 2 sine t cos t for dx by dt. Y we had as being 2 tan t, and then in order to find dy by dt, the differential of tan is sec squared. So that's just 2 sec squared t. And so I want dy by dx, which is going to be dy by dt. And I always remember this for the parametrics. It's multiplied by dt by dx, not dx by dt. So that's going to give me dy by dt, which is 2 sec squared t. But dt by dx is 1 over 2 sine t cos t. And then obviously they cancel. So dy by dx will be sec squared t over sine t cos t. Now we know that t is equal to pi over 4. So t equals pi over 4 dy by dx is going to be sec squared pi over 4 all over sine pi over 4 cos pi over 4. And if we do that, apparently that all works out to be equal to 4, but that means that the gradient of the normal, because that's a gradient of the tangent, the gradient of the normal will be minus 1 over 4. Now the thing I've got to do is to find x1 and y1. So x1 is going to be sine squared, and again we know t is equal to pi over 4. So what does that work out to be? Half. We know that for y1, we're going to be looking at 2 tan pi over 4, and that works out to be equal to 2. So now explain to the examiner what I'm doing. Equation of a normal. Haven't said it to him yet. Y minus y1 is mx minus x1, and what I always tend to do is to write x1, y1, and m here. First of all, I'm less likely to make a mistake, and also, as I'm going through, it just means I check things like making sure that it is the gradient of the normal rather than the tangent, etc. So in this case, x1 is equal to 1/2, y1 is equal to 2, and m was equal to minus 1 over 4. At that point there, that I might have not realised and done the gradient of the tangent rather than the gradient of the normal. So putting that all in then, all that information going in, we get y minus 2 is equal to minus 1/4 x minus a half. Did they say anything about how they wanted it? Oh, right, yeah, we're going to make it equal to that 8y plus 2x equals 17. So going back there, just multiply everything by 4. Get rid of the fraction first of all. So 4y minus 8 equals minus x minus a half. So in other words, 4y minus 8 is equal to minus x plus a half. If we now double everything, multiply everything by 2, we're going to get 8y minus 16 equals minus 2x plus 1. And then tidying that up and making that into the form ax plus by, I'm going to get 2x plus 8y. Now, normally I would have minus 17 equals 0, but actually they've asked me to write it in that format there. So, yeah, absolutely fantastic. Looking at that, we've done part A. Okay, what does part B say then? Part B says, find using calculus the exact area of S. So we need to be careful about this then if we're looking at this. What I'm going to do is just go back to this diagram and just put some points on here. So what I'm going to do is to draw a straight line down there, which will break this up into area, what I'm going to call area A as part of my working out. Area A, oops, and then area B here. So if I do that now, just call this one area A, and this one area B. When I'm trying to work these out, area A will be the area under the curve, but area B I could do, hopefully, as a triangle. Let's put on some points here. I'm going to call that Q, and I'm going to call that R. So what I've got to do, first of all, is to make it clear to the examiner what that value there is. So we knew that the point P was, what we just had it, didn't we? Sorry, let's make this a bit smaller. We said that the point P was half 2. So going back to my diagram, this point here is half 2, which means that when I'm working the area under that curve then, that's going to be between 0 and a half. So let's just do that bit, then we'll do the second bit. So part B, area A is equal to the area under the curve. So the area under the curve is just the integral between 0 and a half of y dx. So that's going to be the integral under the curve, pi over 4 and 0 y dx dt. So I'm changing the limit there because what I need to do is to be able to integrate with respect to t, not with respect to x. So this is standard. If you've done any work on integrating using parametrics, this just works out to be exactly what we're going to do. So this is the integral between pi over 4 and 0 of y. Y was 2 tan t. Dx by dt was 2 sine t cos t dt. So now when we're looking at that, this is integral between pi over 4 and 0 of 2 sine t over cos t, 2 sine t cos t dt. They're going to cancel. Oh, brilliant. And I'm going to get the integral of 4 sine, well, I'm going to take the 4 out, the integral of sine squared t dt. Now, this is one of the classic ones that we should be able to do. I'm going to go through it slowly, but what I've encouraged a lot of my students to do is to know what that is straight away, okay? Sine squared t is a half 1 minus cos 2t, and they know that specifically for this integration. I'll go through it slowly, but some of my students would put that straight in there, but let's do it as though we didn't know it. So if we didn't know it then, we'd say, can I integrate sine squared? No, you can't. So I need to use one of my identities, and the identity we're going to be using is cos 2t is 1 minus 2 sine squared t. If we rearrange that then, 2 sine squared t is equal to 1 minus cos 2t, and so here's where we get sine squared t is half 1 minus cos 2t, because I can integrate 1 minus cos 2t. So here then, I'm going to get my integral as being 4 integral between pi over 4 and 0 of sine squared t, but that's going to be half 1 minus cos 2t. The half is going to go there, and whether you want to write that or whether you want to write that straight away as 2, just depends on how much working out you want to show. I'm going to leave it like that, just so that we've got lots of working in there. And so then that's 2 outside. Let's actually now go ahead and integrate 1 minus cos 2t. So 1 minus cos 2t is going to give me t minus the integral of cos 2t. I'm not spending any time over that, guys. That's half sine 2t. You're going to need to go away and sort out your integration if you can't see that. Between pi over 4 and 0. Now we could put that 2 back in if you want to. So it makes it 2t minus sine 2t between pi over 4 and 0. It doesn't matter when you mess around with that constant there. This just makes it a little bit easier for me to actually do then. Sticking pi over 4 in and sticking 0 in is going to give me pi over 2, and then sine pi over 2 is 1, minus, and the other 2 bits are both going to be 0 when I stick noughts in there. So it gives me an answer of pi over 2 minus 1. Now remember, that's just the area A there. What I'm now going to do, get rid of that, and start focusing on the area B. So if I want to work out the area B here, remember, I know that value there is a half. I know that the height there is 2, but I really need to know what this length here is. Well, that's going to be easy to do because we know the equation of the line. So if it's the equation of the line, I'll just put y equals 0 into that. But let's now go and explain all that for the examiner. So that's area A done. Whoops. So for area B here, area B, if you want to say it's the area of a triangle, remember it's half base times height. To find length of base, we've got 8y plus 2x equals 17, but we know that y is equal to 0. Okay, if that's true, that's going to give me 2x equals 17, which is going to give me x equals half of 17, which is 8.5. So in other words, QR is equal to 8.5. I'm not going to keep going up and down from the diagram. So now area B is half base, which is 8.5, times height, which is 2, which gives us, be careful, sorry, and I'm not going to go back and do this again. I'll actually see that I've made this mistake here. Let's just go back here. The length of all of it is 8.5, but we know that that little bit in there is 0.5. So do not let that catch you out. I've already done this question once before and I made that mistake. So just go back and let's just tidy that up. That's OR that's equal to 8.5, which means that QR is just equal to 8. So we get that the length is half base times height, which is half 8 times 2, which actually gives us 8. So the total area is equal to A plus B is equal to pi over 2 minus 1 plus 8, which is then pi over 2 plus 7. Which is the final answer. Let's just go back and check. Did they ask me to show it's equal to anything? No, but they did say to find the exact area there. So we just need to be careful when we're doing that to find the exact area as we're going ahead and doing all that. Okay, long question. Hopefully that all makes sense to you.